Hello, everyone. Good evening, good afternoon, or good morning, whatever you are. My name is Luis Guirigay. I'm the Senior Global Director and Chief Technical Advisor for HCL Digital Solutions. And I wanted to do this presentation in order to get everybody up to speed, or at least up to the same level where you are better prepared for when all these amazing products, which by the way, same time is already there, but by when all these products are gonna be more and more cloud native ready. So this presentation is about DevOps in Cloud Native for HCL Digital Solutions Administrators, whether you do Domino, same time, or connections. This is a presentation for you. So I'm not gonna go through the agenda, you can read that, but we're gonna try to cover the most important topics that, again, you will have to get familiar with before you start tackling or attacking this implementation of Kubernetes. So the number one topic I want to cover is containers. I think that this is very familiar to many of you, but again, for those that are not, very fast review. What you see on the left is container applications. If you look on the right, a standard application like the ones you have seen for the last, I don't know, 20, 30, 40 years, it's an application that runs on a very specific operating system. So that application or that environment has a full dependency to the operating system. Now, this could be a physical machine, or they could actually be a virtual machine that runs on top of a hypervisor environment. If you look on the left now, what you see is a container or containerized environment where now you see that the applications or the servers no longer have a dependency on the operating system, but instead they run on a Docker or container runtime. And the reason I say about either Docker or any other type of container environment or runtime is because in a few minutes, I'm gonna give you a quick update with an announcement that Kubernetes made just a couple of days ago. Now, in terms of containers, there are actually multiple runtimes environments, many of them. In fact, Docker was one of the first ones and has been kind of the most popular one. There are other containers runtime environments like Creo, Containerd, OpenVZ, and many others. A couple of the benefits that, again, I want to remind everybody that it's not only the no longer a dependency between the application and the operating system, but it's also the ability to run and boot in seconds. The other thing is that containers, they are supposed to be ephemeral. That means that I can take one container or I can take one application, let's say Domino on Docker, or Domino on a container. I should be able to get that container environment up and running within a second. Now, let's say that I have a problem with that container image or that container environment. I should be able to destroy that container and spin up a brand new one, but connect to a data volume sitting outside the container. Again, that's another huge benefit because what it really gives you is the ability to auto-scale almost in real time or downscale based on how much workload you are expecting. Portability, I already talked about the dependency between the operating system and the application. That is not a problem anymore. And the other thing that's important for you to know is the container registry. Again, when I designed this presentation, my focus was Docker for obvious reasons. We're going to be making some updates based on what Kubernetes just announced. But another very important piece of a container or orchestration deployment, it's the container registry. Forget about the Docker container registry for a second. Only think about a container registry. When you look at containers, they are pre-deployed images of any given application. For example, in the case of SameTime, you no longer have to install SameTime. What you need to do is deploy all the containers or all the images required by SameTime where everything is already pre-installed. What you need to do is actually just deploy. So you need a place to store all these images. And for the Domino people in the room, think about containers as the actual NSF, and think about the the image as the NTF, as the template. Having those templates in a specific location is what an image repository or a container registry is. So anytime I have to pull a new container, or I have to pull a new image or deploy a new container, my environment goes to that container registry, pull the image I need, and then deploy on my container runtime. And for those of you that, again, have been playing with Docker for a long time, the Docker Hub is exactly that. It's a public container registry where there are hundreds and thousands and I don't know how many Docker images that you can use, you can pull from the registry and deploy locally as applications. Now, there was a very recent announcement, actually, I would say maybe a week ago, less than a week ago, where Kubernetes, as an open source entity, they announced that they will deprecate Docker shim, starting with Docker 1.23. Now, the reason I'm including this announcement is because, number one, it's not as bad as people might think. I actually got a couple of emails in the last few days after this announcement, like, oh my God, what's happening? Docker is not gonna be supported anymore, all of that. Well, let me actually give you some additional clarity into this announcement. Number one is our HCL development team, product management team, they will provide the proper remediation or fix or changes to the documentation, whatever it is. But I already talked to many of our directors in our development teams, and they said that the impact will be minimal. And again, whatever it is that you guys have to do, we will provide all those fixes as soon as possible. Now, the other good news about this is that this announcement, even though it came December 2020, this is not going to become effective until actually December 2021, because what will happen is that starting with Kubernetes 1.20, people or administrators will start seeing just a warning message that says, after 1.23, we will no longer support Docker shim. Okay, so for now, nothing's happening. All you will see, if you upgrade to Kubernetes 1.20, all you will see is a message. 1.23, Kubernetes 1.23 in late 2021 is when you will actually see a deprecation. Now, the other thing, and by the way, I put the link if you guys want to read more about it. But another piece of news here is that if you look at the commercial Kubernetes operators, they are always running behind the official Kubernetes.io releases. For example, I do believe right now the latest version for Kubernetes that is actually out and stable is 1.19. But if you see OpenShift is running 1.18, GCP is running 1.17, AWS 1.18, and Azure 1.17. These Kubernetes vendors, they actually give you the option to deploy an even earlier release. Like, for example, on GCP, I know I can deploy a Kubernetes environment, whether it's on 1.16 or 1.17. You as a Kubernetes or as a DevOps administrator, you will have that option. So this slide is just to provide peace of mind. Nothing is happening anytime soon. We are very aware of this. The minimum changes that will have to happen, whether it's in our documentation or our products, they will be communicated to our customers and business partners as soon as possible. Okay, another piece of technology that I want everybody to start getting familiar with is YAML. Okay, YAML is basically another markup language. Now, the thing about YAML is that YAML is what's being used for DevOps administration. And Ansible playbooks, and as you guys know, for Connections V7 in particular, we're actually doing a webinar, I believe tomorrow, on how to deploy connection with Ansible playbooks. So number one is Ansible playbooks are a very efficient and fast way to deploy software, where, just to give you an idea, let's say that you have to deploy 22 different servers, right? You could do that manually. You could go to every single machine and do what you need to do, maybe update the operating system, maybe update security patches, maybe install a database, maybe install ABC. With playbooks or with Ansible playbooks, you can actually automate all of that and create, again, playbooks. And those playbooks, what it gives you is the option that from just one machine, I can run the command, and then this playbook is going to touch each of those 22 servers in parallel or in serial way, and it's going to do whatever it needs to be done, right? And that's exactly what the connections playbooks or the Ansible scripts do. They automate a lot of the manual steps that you had to do with connections in the past. So back to YAML, the reason why I want all of you guys to start getting familiar with YAML is because playbooks use YAML. YAML is a very particular language. It's very picky, if that's a word I can use. So you have to be very careful with indentation. You have to be very careful with the spaces. Do not use tabs. YAML hates tabs. But my number one recommendation here is that when you start working with YAML, please use a YAML editor. It will make your life very, very easy. Okay, the next one is Helm charts. Helm charts, or Helm, it's an operator that in the world of Kubernetes, it basically becomes your application manager. So think about Windows, right? When you want to install Notes, when you want to install same time, you install the product using the Windows Installation Manager, whatever it's called. I use Mac, so I don't remember now. But when you want to uninstall it, same thing. You go to that application management UI, you select the product you want to uninstall, you click uninstall, and that installation manager is going to go through every single file, every single Windows registry that needs to be modified and remove it. Helm does exactly that in Kubernetes. What it really does is, let's say that I deploy my same time images or my connections images in the container registry, and now I want to actually install or deploy the app. The command is pretty simple. Helm install, let's say same time meetings, and then I provide all the YAML files that the Helm chart will use to set up the environment. By the way, another reason that you need to learn YAML is because Helm charts are written on YAML. So when you install same time, there are a set of settings or parameters you will have to pass to Helm, and all those parameters will be on YAML. Like, for example, when you are installing same time, you need to pass parameters like what's the IP address, what's the fully qualified host name of the proxy server, how many users you want to set up as the maximum for your environment, or the tokens and the single sign-on configuration. All of that you will do on a YAML file. So back to Helm install same time, and then I will provide a path to my YAML directory where all this information will be there. If I no longer want to use the app, all I have to do is Helm delete my app, upgrades, rollback. It's amazing. Like, let's say that you are deploying same time 12, right? You install same time 12, perfect, within 5 seconds, and I will actually show you a very quick demo of that if we have time at the end. Now same time is up and running. And again, it takes 5 seconds for the Helm process to actually download the containers or the images and deploy the containers. Let's say that 6 months later, you want to deploy whatever the next version is for same time. Let's say 12.5. Helm, upgrade, same time, and the YAML files. Boom, within 5 seconds, now you are on 12.5. Oh, 10 minutes later, you might have realized that there is a problem with the product, there is a bug, or I don't know, something is happening, and you want to roll back. The process is extremely simple, and all of you guys, system administrators, will love this. The moment you realize that there is an issue, right, with any specific release, you can roll back, again, in less than 5 seconds. All you have to do is Helm, roll back, same time, and what revision or what release you want to go back to. How do you know that? You can do Helm history, application, same time, connection, domain, or whatever, and it will show you what are all the releases deployed, and then you can say, oh, you know what? I have deployed 3 releases. I don't want to go to the last one. I want to roll back to the one before the last one. Yes, you can absolutely do that, and it's extremely, extremely easy. Okay. Another thing I would like to talk about here is Terraform. So Terraform is another kind of operator that helps you deploy software. At some point, it's up to you, what's your preference, where do you have the skills. But one thing about Terraform is that with Helm, you deploy applications or workloads on Kubernetes. Sorry, with Helm, you deploy applications or workloads on Kubernetes. But with Terraform, you can actually deploy the whole thing. You can deploy the whole infrastructure, right? So Terraform basically takes that Helm application management use case all the way to the next level, and not only helps you manage the application, but also the infrastructure. So again, these are concepts that I'm giving you for you guys to starting to realize that if you have never done anything DevOps, if you have never done anything Kubernetes, this is just for you to kind of go back to it and say, oh, okay, I remember that Luis talked about Terraform, so now I understand what it is and whether I want to learn more about it or not. But for Helm, absolutely, because that's what SameTime uses. It is what Digital Experience uses. I don't remember right now for connections if it actually uses Helm. It might, but just come to that connections webcast tomorrow and you will hear about it. Okay, now let's talk about Kubernetes. What I like to do with this specific slide is demystify what Kubernetes is. Kubernetes is not a black box that you don't know what's going on. Kubernetes is not an environment where, it's all these virtual things that you just don't understand and you don't have access to them. So Kubernetes in reality is a cluster of compute power. I'm pretty sure you heard nodes before, worker nodes and master nodes. And let me tell you what they are. They are just VMs. In this screenshot right now, you have a couple of different components. So let me go one at a time. The one on top, that's the control plane. The control plane, in this specific case, have 3 master nodes. That means that you have 3 physical machines or VMs that are acting, each one of them as a master node. When you set up a Kubernetes cluster, if you deploy on-prem in particular, you will have to go through the process of finding 3 VMs or 3 physical machines. They actually don't require that much compute power. I think that many of them go with a 4 CPU or 8 CPU, 4 GB of RAM, or maybe 8. Again, it's very minimal. But you will have to go through the process of finding those VMs or physical machines, installing a few different components for them to be aware of each other. The moment that these 3 VMs become aware of each other and now you install the appropriate components, now they become the control plane. Now, what you see at the bottom is the data plane. I didn't really put data plane here because not that many people use it. So again, might just create confusion for you guys. But the worker nodes, that's called the data plane. Now, the worker nodes can be organized in different ways. One thing is node groups. In the particular case of SameTime, and we will talk about that in a few minutes, SameTime uses 3 worker nodes to operate. 1 worker node for the main component, another worker node for the video component, and another worker node for the recorder component. Now, the reason we organize worker nodes into node groups is because my node group on the left, that is only one worker node, that might have different sizing requirements from my other worker node. So for example, my VM or physical machine on node group number 1, which is only one worker node, that one, it's only 2 cores and 4 GB of RAM, and that's all I need. If I need that worker node to be able to autoscale, every other VM or every other machine that will autoscale inside that node group will have those hardware specifications. Now, my second node group, that could be a 8-core 16 GB, and my third node group could be a base image of, I don't know, let's say 32-core 64 GB of RAM. The whole idea here is that you minimize the need for allocating compute power you don't need, okay? That's part of the idea. Make sure that you are not allocating more compute power than you need. And again, this is completely based on the application. I mean, maybe your application needs that even if you don't use it, not the point here. But if you want to autoscale, some companies, some applications, they prefer to autoscale smaller, so they add as they need, versus other applications, they prefer to do just one autoscale, you know, and maybe 2, and that's it. What else? Oh, the other thing you can do with node groups is to decide, like my first node group, I want to be able to say that it will always have at least 2 worker nodes, and it will not be able to autoscale to more than 5. But my second node group, I want to set up that a little bit different. I want to set up my second node group that it will always have 2 worker nodes running at any given time, and that one can autoscale all the way to 20 worker nodes. And my last one, I can set it up that by default, the moment that my application starts, it will always have 4 worker nodes, but it won't be able to scale past 4, or it won't be able to scale past 50, or autoscaling altogether is disabled. So that's another way that node groups are very useful. Okay, now the next topic here, or the next item, is very important for you to realize what's the minimum or the smaller kind of unit in a Kubernetes cluster, and that's called pods. In this case, now you know what a worker node is. A worker node is just a VM or a physical machine that is part of a Kubernetes cluster. Now, in any of these worker nodes, you can deploy pods. The containers, the images that you pull from the container registry, they don't go directly into the worker node. They are actually organized into pods. And these pods, you can have one or many running on the same worker node. You can do things like, for example, you can have multiple pods having multiple set of containers running on the same worker node, or you can have an application that have the same pod multiple times on the same worker node. It's completely up to how the vendor designed the application. But one thing I want to show here is the autoscale capability. One thing you can do in Kubernetes is to define what your autoscale requirements are. For example, I want to say that the moment that my worker node hits 75% CPU capacity, I want to automatically autoscale. So that means that the moment that that CPU on that specific worker node gets to 75% utilization, I'm gonna immediately autoscale and I'm gonna create another worker node. Or I can say when it hits 90% or when it hits 60%, is completely up to you as an administrator. Now, it doesn't really auto-scale immediately in a way that, you know, oh, I need to auto-scale, I'm gonna create another worker node. There are a few pieces that happen before that. Number one is you first auto-scale at the pod level. I need more resources. So the first step, and again, this is kind of based on the application. Some applications or some vendors, they have a mandate that is only one pod per worker node. I have seen products like that. I have seen other products where you can actually deploy multiple pods. But let's say with the generic statement that, you know, you are working on an application, or you are deploying this application and you need to auto-scale. Well, it's gonna try to create more pods on the same worker node because the CPU or the compute power capacity is still less than 75%. At this point, when you have this many pods running on this specific worker node, Kubernetes now realizes that, oh, I'm at 75% capacity, I cannot allow more pods on this specific worker node. So what Kubernetes will do is it will create a brand new worker node and will start allocating those new pods on that new worker node. Okay, that's the basic concept of auto-scaling. I'm going to talk about this in a few more minutes, but deploying Kubernetes on-prem and deploying Kubernetes on cloud is very different, because when you deploy Kubernetes on-prem, you need to have, if you want your application to auto-scale, you need to have that compute power available and ready to go for when Kubernetes needs it. If you deploy on things like GCP, Amazon, you know, Azure, or IBM Cloud, that compute power, you only pay for what you use it, but it doesn't really need to be available, so you don't pay for it in advance. But again, I will talk about that in a few more minutes. Now, another very cool feature in Kubernetes is namespaces. Namespaces have a couple of different purposes, and I'm gonna kind of highlight two. Again, we have a Kubernetes cluster that's a combination of compute power. You have the control plane on top, which is 3 master nodes, and then you have the worker nodes and the node groups at the bottom. One thing you can do with Kubernetes is to create namespaces, and think about namespaces as folders or projects or specific applications. For example, you are not expected to create one Kubernetes cluster for every single cloud-native application you have to deploy. Let's talk about HCL digital solutions. You have same time, you have connections, you have Domino, and you have DX. Let's say that all these products are now 100% Kubernetes, 100% cloud native. You will not have to install one Kubernetes cluster for each of these workloads or each of these applications. What you need to do is to create one single Kubernetes cluster and to create a namespace for each deployment. In fact, one of the parameters when you do a Helm install is to provide the name of the namespace. If you try to install same time, if you install same time and you don't provide any namespace, it's going to install it in a namespace called default. But if you install connections, or if you install any other product and you say Helm install and you provide the name of a namespace, it will install that workload in that namespace. And at the end, what it really gives you is a very nice way to organize your environment, okay? Otherwise, when you go into connections, you will see that, when you go into Kubernetes, you will see that every single application, every single worker node, they are all mixed together, and then you will have to do some extra work to find which worker node is with which application in which pod. It will take time. But if you use namespaces, it will make your life much easier because you can say, okay, show me all the worker nodes or show me all the pods working in the connections namespace, and boom, very easy to filter and see what is actually running that belongs to connections. Let me show me all the pods running for this other product, right? And then you provide the namespace for that product, and it will show you specifically for that. Now, the second benefit or the second use case for namespaces is you can actually control resources utilization. I'm not gonna go deeper into that, but with namespaces, you could actually go one level higher and provide additional controls for CPU and resources utilization within the Kubernetes cluster. Okay, I have about 10 minutes left before questions, so I think I'm good. So the next topic here is storage, okay? I mentioned a few minutes ago that containers are ephemeral, so you should be able to destroy, reboot, restart, scale down, scale up containers as you need. But one very important piece is that if containers are ephemeral, you need to make sure that whatever data those containers interact with doesn't get destroyed, right? So let me go from the bottom up. Let's say that you deploy a Kubernetes cluster in your organization. Let's say that in your data center, you have 200 gigabytes of storage. And that could be physical storage, that could be cloud storage, or that could be a combination of both. So, okay, I have 200 gigabytes available. What do I do with it? How do I give it to my Kubernetes cluster? Well, the first step is to tell Kubernetes that, hey, I need to create a persistent volume of 20 gigabytes. This means that out of the 200 gigabytes that you have available, you are now allocating 20 gigabytes to the entire Kubernetes cluster, okay? So now when you load your Kubernetes cluster for the first time and you set up the persistent volume, now your Kubernetes cluster have literally a 20 gigabyte space for Kubernetes to use. The next step after that is, okay, I have 20 gigabytes available for Kubernetes. Now I need to decide how much space I want to give to each application. So the next step for you is to create what's called a persistent volume claim. What it is if you look at this graphic, I have 200 gigabytes total from where I gave 20 gigabytes to my Kubernetes cluster. But now my next step is that for this specific app or for this specific pod, I'm gonna take a persistent volume claim and I'm gonna allocate 10 gigabytes out of the 20. I cannot take 10 gigabytes out of the 200 because the pod is not capable of going all the way down to the complete amount of storage. The pod will always have to work with the Kubernetes cluster, and that's kind of what the control plane does. The control plane is the master nodes, is the management piece of a Kubernetes cluster. So now I have an app that is using 10 gigabytes out of the 20. At this point, I could add more applications, whether they are on the default namespace or they are on different namespaces, but I can create more applications that can now use the 10 gigabyte remaining. It could be one for another 10 gigabyte. It could be 5 different apps or pods that each of them, they do a persistent volume claim of 2 gigabytes each. It's totally fine. Now, there is another component here, which you see on the left, is the storage classes. Let's say that, okay, this Kubernetes cluster, you gave it 20 gigabytes, and now you have one app using 10, and you are about to deploy another app that actually requires 20. Because you only have 10 gigabytes available, you won't be able to. So what storage classes do is, without you as an administrator having to manually create another persistent volume, right, with, I don't know, let's say 50 gigabytes, so that new app can now use those 20 or claim those 20. What storage class will do is it will act almost like a template that on demand in real time, when an application requires more space and is not available in the persistent volume, Kubernetes will use the storage class as a template to allocate more available space into the cluster, so then you can create new persistent claims out of those persistent volumes. Okay. Deployment options. You can deploy Kubernetes on-prem, you can deploy Kubernetes on cloud. If you deploy Kubernetes on-prem, there are a few things you need to do. Number one, you have to set up your control plane. Your control plane is at the bottom. You see 3 master nodes. 3 is kind of the recommended number. I don't really remember seeing, like, for production, definitely do not use 1, right? For development, you're fine. For testing, you are okay. But for production, the recommended number is 3. And especially because they have a kind of election process type of failover high availability, so they need to be in an odd number. Remember, each master node is a physical machine or a VM. So what you need to do now is, if you are doing on-prem and you are installing each master node, you have to go through the process of installing the API server, the controller manager, the scheduler, and the etcd, which is basically the key store database where all the configuration is stored. You can do that manually. There are Ansible playbooks that do this for you, but the next step is to do the second master node and the third master node. But if you're doing more than one, you need to deploy a load balancer in front of them. As I said, it might sound complicated, but it is not that bad, right? It's actually, once you have done it once or twice, it will be pretty easy for you, because another reason I like to do this session is to, again, demystify what Kubernetes in clusters really means. So there are playbooks where if you already have 1 VM or 3 VMs for your master nodes, you can actually use playbooks that with 1 click or with 1 command will actually go through all these servers and will install everything that needs to be installed. And then after you have your control plane or your master nodes, then you start working on the worker nodes. For the worker nodes, it's a little bit of a much simpler process, because you just need to install the required components on each worker node to let them be aware that they are now part of a Kubernetes cluster. And guys, I like to repeat this over and over. What you see right now on this screen, it's basically 7 VMs or 7 physical machines. You have 4 VMs, and I'm just going to stick with VMs. There are 4 VMs, and each of these worker nodes is an actual VM. Could be same hardware configuration, could be different. That's another point. And then you have the master nodes that each of them are a different VM. With playbooks, you could actually automate the process where every single individual component that needs to be installed on every single VM, you can actually use a playbook where there is a file where you put all the variables, like these are all the IP addresses of all my servers and all of that. You can actually do that playbook, and the playbook with 1 command will go through each VM and will install everything that needs to be installed. Okay, deployment options. At least that I'm aware of, or at least the most popular ones, there are 5 different options for you to deploy Kubernetes. You can deploy EKS, which is Elastic Kubernetes Service from AWS. You can do GKE, Google Kubernetes Engine on Google Cloud. You can do Kubernetes, which is also named Vanilla Kubernetes. That's the open source kind of free one. You can do Google Kubernetes Engine, which is kind of the on-prem edition of Google Kubernetes. And then at the bottom, you have Red Hat OpenShift, which you can do on IBM Cloud, or you can do Red Hat OpenShift on-prem. You also have a AKS, which is Azure Kubernetes service, and VMware, they actually have a Kubernetes service where this whole process of allocating compute power on demand, VMware can actually do that, and VMware will create the VMs on the fly as you need them, and that's part of VMware Tanzu. Now, where would you deploy Kubernetes? It's completely up to you. My opinion on cloud is the easiest way to do it and the faster way to do it. Number one, it's called managed Kubernetes, meaning that if you deploy AWS, JKE, or Red Hat, or Azure, you don't have to install the control plane. The control plane is actually given to you as part of the deployment. You don't have to, you literally forget about the control plane. That's part of the managed Kubernetes process. I don't know about the other vendors. Again, a lot of the work I do is with GCP and AWS, but for example, AWS charge you, I think in the US region, 10 cents an hour for the control plane. Basically, 10 cents an hour for the whole Kubernetes cluster without worker nodes, right? So think about this. If you deploy on-prem, you have to install 3 VMs. If you deploy on cloud, I mean, you just literally don't care because it's a managed Kubernetes service and you only have to pay 10 cents an hour. So it's actually pretty low. Less complexity. It's literally next, 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 or maybe a couple of commands using a YAML file, and that's pretty much it. Now, why would you deploy on-prem? You can absolutely deploy on-prem. My opinion is that if you are in a highly regulated industry, defense, healthcare, government, maybe internet access is not allowed, or your company is kind of cloud advert, you don't really like anything on cloud, absolutely, you can do on-prem. Another reason for you to go with on-prem is that if you already have Kubernetes deployed. I talk to many customers and many of them, they already have Kubernetes. It makes no sense to go into any other cloud. So, and finally, you know, some companies, again, especially regulated industries, they have this whole thing that no internet access. So that's another situation that would drive you on-prem. But guys, full transparency here. It's your choice. You decide how you want to deploy. Just be aware that if you deploy on-prem, there is a little bit of extra complexity because now you have to deal with master nodes, you have to deal with load balancers, and something like Red Hat OpenShift actually does a lot of that for you. VMware also does a lot of that for you. But if you deploy with vanilla Kubernetes on-prem, you will have to do some of these pieces manually. So I had a demo. I don't think I will have time for the demo. I'm gonna kind of drop it right here. So what I would like to do at this point is go into Q&A. Now, one thing that I'm gonna give you guys when I send this presentation back to the Russian user group team, I'm gonna add a couple of additional links. Guys, there are hundreds, if not thousands of tutorials or guides or white papers of how to do Kubernetes cluster. There are plenty of them. So I don't really want to point you in any specific direction, especially because I don't know the attendees in this call, but many of you may be Russian, of course. So you will prefer to use some Russian-based documentation, but just Google it. There are hundreds and thousands of documents out there that will show you how to create a Kubernetes cluster, you know, pretty quick. Another thing I would like to mention is that for same time in particular, we just published a white paper for deploying same time on AWS. That white paper, if you download it, right, just look into our tech notes, Twitter, you know, if you don't find it, send me an email, I'll send it to you, but it's out there as a knowledge article in our support site. If you look at that document, 85% of the document is actually just getting Kubernetes up and running. That's what it is, 85%. The same time piece is actually minimal. It's just a few commands and a few changes. And a lot of the process is just, you know, creating resources on AWS. But myself, after installing same time, let's say twice, I'm now able to deploy the complete same time suite, Mongo, same time chat, proxy, and of course the meetings component in less than 4 hours. Getting the Kubernetes cluster on AWS takes about 60 to 90 minutes, between Kubernetes and same time meetings. And the other, 2 hours plus is actually getting Mongo community, LDAP, proxy, and everything. So we have about 10 minutes left. Should we do Q&A now?
Hello, Luis.
Hello.
Здравствуйте, Луис. Мы сейчас переходим к последовательному переводу.
Good evening, Luis. So we will start our Q&A section, and here we will have consecutive interpretation.
Благодарим вас за презентацию.
Thank you so much for your presentation.
У нас нет вопросов от наших участников и слушателей.
We don't have any questions yet from our participants.
Но есть один комментарий.
But there is one comment.
Хотел задать вопрос по Kubernetes, но Луис уже ответил на него в презентации. Круто! Передайте спасибо от меня.
So this comment says, actually, I wanted to ask one question, but Luis has already answered my question before I had an opportunity to ask it. So thank you so much. It was really awesome.
Happy to hear that.
Я очень рад.